Hello there and welcome to this problem. So the biggest clue here is that these shapes are similar because work at the volume of the largest shape to 1 dp. Now, first of all, it's giving you surface area of this and this, and it's giving you the volume of this one and this one. Okay, so just to remember that the way we go about this is you look at the scale factor. So this one's gone bigger. Okay, so first of all, the surface area, so it's area, and the scale factor is going to be this number here, the 435 centimeters squared, millimeters squared, shared by 165. So if we get this scale factor, 435 divided by 165, you got 29 over 11. Not a nice number, but that's our scale factor for the area. Now, before we get the volume, we should know that the scale factor for the length, okay, is going to be the square root of this. So 29 over 11 square rooted is the scale factor for the length. And once we got that, we can then work out the scale factor for the volume. Is going to be this scale factor cubed. Okay, just put that out there. So you got length, you got area, and you got volume. This scale factor when the similar shapes is whatever that scale factor. So I'll just draw two shapes here. So if this is a length, just call it 1, and this is being multiplied by k, so the scale factor was k times bigger. Good. Now when we deal with area, let's say let's call this, if that was, let's call that 1. I know this one's ridiculous now because that looks much bigger. Let's just call this 5. But if I multiply this by k, then 1 times k is 1k, and 5 times k is 5k. And notice the area here will be 5 times 1 is 5, and the area here will be 5k times k will be 5k squared. Okay, so what happens is, because this got stretched by k and this got stretched by k, the area got enlarged by k times k, which is k squared. And then last one is volume. So if this was, let's just say this was 4, just to keep the maths, actually let's call that 2 just to keep the maths simple, and let's say this is being times by stretched by k, so that now becomes 2k. So the volume here will be 1 times 5 times 2, which is 10, and this will be 5k times 2k times k, which will give me 10k cubed, because that's been stretched by k. This length has been stretched by k, and this length has been stretched by k, because that was the initial scale factor, and therefore the volume actually becomes that cubed. So the scale factor is cubed when you get the volume. So if that makes sense, then this will all make sense, that from the area we get a scale factor, and then we square root it to get the length one, and then once we got this length one, which acts like k, that needs to be cubed to get that. Obviously this squared is 29 over 11, which is being squared. So once we got that scale factor, we just literally times 90 by 29 over 11 to the power, now square root is to the half, so that will be 3 over 2. If I do that on my calculator, open bracket 29 over 11, close bracket, to the power 3 over 2, and then multiply that by 90, you're going to get the volume of 385. Now it says to one decimal place, and that will give it 385.3. Because the answer here goes 3 on my calculator, 385.256, etc. And because I'm rounding it to one decimal place, which is this is 2. Now if it's 5 or more, the next number to 2, you round up. If not, you leave it be. In this case it's 5, so we round up. Okay.